Tonight, we are stepping into a question that sounds simple at first, then grows stranger the farther out we go. How small are we really? By the end of the night, you will see that answer from more than one distance. You will see how quickly a human being disappears against the size of Earth, how Earth itself begins to shrink once space opens around it, and how the feeling of being large or small depends almost entirely on the frame we place ourselves inside. At first, a person does not seem especially small. You move through rooms at full size. You stand in doorways without feeling miniature. You cross parking lots, sidewalks, and hallways as if the world has been built around your body. Because in many ways, that is how daily life feels. A chair matches your height. A staircase fits your stride. A ceiling feels high because you can look up at it. Nearly everything you experience is measured against human proportions, so human size begins to feel normal, balanced, and central. That feeling is powerful because it is constant. From the inside of your own life, you do not feel like a tiny creature standing on a planet in space. You feel like yourself, moving through a world that seems large in some places and small in others, yet always understandable. A building feels tall, a field feels wide, a mountain feels enormous. These things give the impression that you live at a meaningful scale, large enough to matter, large enough to stand inside the scene and make sense of it. Then the frame begins to widen. At first, the change is almost gentle. From a few meters away, you still look like a person. From a rooftop, you become smaller, though still easy to find. From much higher up, something begins to happen. Your outline softens. Your body becomes harder to separate from the ground around it. You stop looking like a person in the full, everyday sense and start looking like motion, then like a mark, then like something the eye could miss entirely. You do not need to travel into deep space for that to happen. You only need distance. A human being is usually about 1.5 to 2 meters tall. That is enough to feel solid and full-sized in ordinary life. Yet Earth is about 12,742 kilometers wide. Those two scales do not sit anywhere near each other in the same kind of experience. One belongs to footsteps, reach, and body height. The other belongs to a world so large that even the tallest mountains and widest countries become small features on its surface. Even cities begin to give way once the camera climbs high enough. From orbit, neighborhoods flatten into texture. Roads become thin threads. Buildings lose their identity and blend into shapes and colors. What once felt massive from street level begins to look like pattern. A human being is already gone from view long before that. By the time Earth appears as a whole world, there is no visible trace of any individual life moving across its surface. That is the first real shift in perspective. Your size did not change. Your life did not change. The only thing that changed was the frame. And the moment the frame widened, the meaning of large changed with it. That idea reaches farther than it first appears to. A thing can feel enormous at one level and nearly vanish at another. A tree is large beside a person. A mountain is large beside a tree. A continent is large beside a mountain. Each step outward changes the story without changing the object itself. What once dominated the scene becomes one detail inside a wider one. Size begins to reveal itself as something relative, something that depends on what surrounds it and how far back you stand. Earth teaches that lesson quickly. From the ground, Earth does not even feel like an object. It feels like the setting of everything. The place beneath your feet, the horizon ahead of you, the backdrop of every ordinary thought. Yet the moment you picture it as a sphere, whole and floating in space, the mind has to adjust. The ground becomes a globe. The familiar becomes measurable. The world that felt endless becomes something with width, edge, and scale. And once that happens, another thought begins to rise with it. If a person can disappear this quickly against Earth, then Earth itself may begin to disappear just as quickly once the frame widens again. And that is where the next shift begins. Once Earth becomes something you can picture as a whole, the feeling of standing on an endless world starts to loosen. The planet still seems large, of course. It holds oceans, deserts, mountain ranges, storms, forests, and cities spread across enormous distances. To the people living on it, Earth feels complete. It feels broad enough to contain everything. Yet the moment you place that globe into space, another truth begins to press in around it. Earth is large to us because we live on its surface. Space does not judge size that way. From the ground, a journey across a country can feel enormous. A flight across an ocean can feel larger still. Even the idea of circling the whole planet carries a sense of scale that seems almost final, as if going around Earth means reaching the edge of what ordinary thought can manage. But once Earth is seen from outside, its size becomes more specific, more measurable, and strangely more fragile. Earth is about 12,742 kilometers wide. That is a real number, and it is large enough to deserve respect. It gives us room for continents, weather systems, long migrations, and all of recorded human history. Yet space around Earth opens so quickly that the planet begins to feel less like a vast world and more like a single object suspended in a much larger dark. The first nearby sign of that is the Moon. The Moon is about 384,400 kilometers away from Earth on average. That distance is easy to say and hard to feel until you compare it with Earth's own width. If Earth is a sphere just over 12,000 kilometers wide, then the Moon sits far beyond it, not close overhead in any ordinary sense, but at a distance about 30 Earth widths away. In the night sky, the Moon feels near because we can see it so clearly. In space, it occupies a wide gap. Even this first step outward already changes the mood. The Earth-Moon system is often imagined as a close pair, and in one sense it is. The Moon is our nearest neighbor. Light can travel from the Moon to Earth in a little over 1 second. Astronauts have gone there and returned. In human terms, that gives the Moon a sense of nearness. Yet when you picture the gap honestly, Earth starts to look smaller than you expected, and the empty space around it starts to matter more. Then the Sun enters the picture, and the scale shifts again. The Sun is about 149.6 million kilometers away from Earth. That number is so much larger that the mind has trouble placing it beside the Moon distance in any meaningful way. The Moon already seemed far. The Sun is vastly farther, separated from Earth by a gulf so wide that light, moving faster than anything else in the universe, still takes about 8 minutes and 20 seconds to arrive here. Every sunrise you have ever seen began its journey minutes earlier. That warm light crossing your room in the morning has already traveled across 149.6 million kilometers of space. Earth, which felt like the setting of everything, is sitting at one point along that path, circling one star at one distance that happens to allow oceans, clouds, weather, and life. The planet has not become unimportant. It has become placed. It now has a position, a scale, and a surrounding emptiness that changes how it feels. This is where the shrinking becomes real. Earth is no longer the full frame. It is one object between other objects. It is one sphere beside a moon, one planet circling a star, one world moving through a region where the gaps themselves are far larger than the things inside them. The space around Earth is already teaching the same lesson as the pullback from a person. What felt immense at one level can begin to look small the moment the frame widens. And the widening has barely begun. Because even this local neighborhood, with Earth, the Moon, and the Sun, is still only a tiny piece of a much larger structure. Before we move farther out, though, something important becomes clear. The difficulty is not just that the numbers are large. It is that human experience was never built to feel them properly. We can hear them, repeat them, and even compare them, yet the full weight of them slips away unless we find a better way to picture what those distances truly mean. That is the strange part about these numbers. They are real. They are measurable. They can be written down with perfect accuracy. Yet the moment they grow too large, they begin to lose their shape inside the mind. You can hear that the moon is about 384,400 kilometers away. You can hear that the sun is about 149.6 million kilometers away. You can even remember those numbers for a while. But remembering a number and feeling it are two very different things. That gap matters. In ordinary life, your sense of size works well enough. A room makes sense because you have walked across one. A road makes sense because you have followed one into the distance. A town, a river, a building, a field, a bridge, a stadium. Even a whole city can still be imagined through movement. You know what it means to cross them, wait inside them, look up at them, or see them shrink as you move farther away. Your body has a relationship with those distances. They belong to experience. Space begins to leave that world behind very quickly. A room can be crossed in seconds, a street in minutes, a city in an hour or two, a country in longer travel, though even then the journey still belongs to human life. You can picture airports, highways, sleep, daylight, weather, and passing time. There is still something to hold on to. The scale is large, but it remains connected to things the body understands. Then the jump begins to widen. A planet is no longer just a larger version of a city. A star system is no longer just a larger version of a planet. These are changes in scale so extreme that they stop feeling like the same kind of thing. The difference between a room and a city is large, but both still belong to human movement. The difference between a city and a planet is far greater. The difference between a planet and a star system widens again so sharply that raw numbers begin to flatten instead of deepen. This is why cosmic facts sometimes slide past people without landing. The numbers are too large to feel in a direct way. After a certain point, one huge number starts to resemble another. 1,000,000, 100,000,000, 1,000,000,000, 100,000 light years. The words still mean something mathematically, but inside the mind they can begin to blur into one soft idea. Very far, very large, very beyond me. Once that happens, the details stop helping. They remain true, but they no longer create a picture. That does not mean the numbers failed. It means the human nervous system was built for something else. You were shaped by distances that matter to survival, shelter, work, and movement. Distances you can walk, run, climb, carry, or see. Your instincts are excellent at handling nearby scale. They can tell whether something is close enough to reach, tall enough to fear, wide enough to cross, or far enough to take time. That kind of judgment belongs to daily life. It works beautifully on Earth. Cosmic scale asks for a different kind of understanding. It asks you to imagine things you will never walk across. It asks you to think about distances where whole planets become small points, and where even light, moving at the greatest speed known in nature, still needs minutes, years, or far longer to cross the gaps. The issue is not intelligence. It is translation. The numbers need help becoming visible. That is why comparison matters so much. A good comparison gives the mind something solid to stand on. It takes a distance too large to feel and brings it into a form that ordinary experience can begin to hold. Suddenly, Earth can become the size of a marble. Suddenly, the moon can sit a little farther away. Suddenly, the sun can appear as something much larger, much farther, and much lonelier than a simple diagram ever suggested. The facts remain the same, yet they begin to breathe. That is the difference between hearing a scale and seeing one. Once a model enters the story, the distances stop floating as abstract facts. They begin to relate to one another in a way the viewer can follow. One object sits here, another sits far beyond it. The emptiness between them becomes part of the picture. Size gains shape. Distance gains mood. The invisible becomes more imaginable. And that is what we need now. Because if Earth is already shrinking inside its own neighborhood, then the only way forward is to build a better frame. A frame small enough for the mind to picture, yet honest enough to carry the true proportions of space with it. So the next step is to give all of this a shape the mind can actually hold. The real solar system is too wide to feel directly. The numbers are honest, but they drift away unless something brings them down to a familiar size. That is why scale models matter so much. They do not change the truth. They translate it. They let us shrink something enormous into a form that can sit inside a room, a street, a park, or a field, while keeping the real proportions alive. One of the simplest ways to do this is to shrink Earth until it becomes something small enough to hold in your hand. Imagine Earth as a marble. A real marble is only a few centimeters wide, yet it is large enough for the eye to notice and small enough to feel ordinary. Now imagine that this marble is our planet. Every ocean, mountain range, cloud system, desert, forest, and city has been compressed into that little sphere. Everything human beings have ever built now belongs to a surface small enough to roll across a table. At once, the scale changes. The moon, which can seem close in the sky, no longer hangs just above that marble. On this model, it would sit some distance away, still nearby compared with everything else to come, but far enough that the gap becomes part of the story. Earth and moon stop feeling like two objects pressed together in a neat diagram. They begin to feel like a pair separated by real space. That alone is useful. It gives the Earth-Moon system room to breathe. But the bigger surprise arrives when we place the sun. Most people carry around a quiet picture of the solar system that comes from books, posters, classroom walls, or screens. In those pictures, the planets are lined up close together, so they can all fit in view. The distances are squeezed. The emptiness is reduced. The result is helpful for naming the planets, but it gives a false feeling of closeness. It makes the solar system seem packed, almost cozy, as if the sun and planets belong to one compact family, gathered in a small space. A real scale model breaks that feeling very quickly. If Earth is a marble, the sun would be much larger, large enough to dominate the scene, and it would sit astonishingly far away from that tiny Earth. Far enough that you would no longer experience the solar system as a cluster of objects, but as a handful of small worlds scattered across long stretches of emptiness. The sun would still be the center of local gravity. It would still be the great source of light and warmth. Yet on the model, it would feel less like a nearby lantern and more like a distant anchor. That is what makes scale models so powerful. They return space to space. They allow the emptiness between objects to become visible instead of hiding it. And that emptiness matters. Without it, the solar system feels simpler than it truly is. With it, the local neighborhood of Earth changes character. It becomes wider, quieter, and much less crowded than the eye was taught to expect. This is also where something else becomes easier to understand. Earth is small. We already felt that when compared with the moon and sun. But once Earth becomes a marble, that smallness turns concrete. You can picture it. You can almost pick it up. You can imagine standing beside it. The planet no longer exists only as a number. It becomes a tiny object inside a larger arrangement. And that arrangement begins to feel more honest because the distances finally begin to stretch out the way they should. The moon remains close enough to keep Earth company. The sun remains large enough to rule the system. Yet both now sit in a layout that exposes something easy to miss when everything is drawn too close together. Our local part of space is already mostly made of gaps, mostly made of distance, mostly made of dark room between the few objects that draw our attention. And this is still only the beginning. Because if a simple model can spread just Earth, the moon, and the sun so far apart, then the full solar system may be much less like a tidy row of planets and much more like a vast, sparse structure where the empty parts do most of the talking. And once that smaller model settles into place, the real shape of our neighborhood begins to feel different. The solar system is often introduced as a collection of planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. A neat order, a tidy sequence, something that can be printed across a page or lined up on a classroom wall. It feels organized, almost compact, as if the main story is the planets themselves. But the deeper truth is quieter than that. The solar system is far less about the planets than it is about the enormous spaces between them. That is the part the familiar diagrams usually cannot show. If they displayed the true distances, most of the page would be empty. The planets would become tiny marks scattered across long stretches of nothing visible at all. The inner worlds would huddle a little closer to the sun. Then the gaps would begin to widen, and the whole system would start to feel less like a row of objects and more like a vast region where a few small spheres happen to be moving through an immense dark. Even the sun, which contains almost all the mass in the solar system and feels overwhelmingly large beside Earth, occupies only a tiny part of the system's total span. It dominates by gravity and by light. Yet even it does not fill the neighborhood. Most of the solar system lies far beyond the sun's visible body. Most of it is distance. That changes the feeling of local space. From childhood, many people absorb an image of the planets as destinations standing one after another, almost like stops along a path. Mercury, then Venus, then Earth, then Mars, and onward. That picture helps with memory, but it hides the mood of the place. The real solar system is quieter, lonelier, and more spacious than that. The planets are present, but they do not crowd the scene. They barely interrupt it. Earth helps reveal this very clearly. Our planet feels full because it is full. Full of air, weather, water, sound, movement, and life. There is always something happening here. Even silence on Earth is shaped by wind, gravity, warmth, and the nearness of the ground beneath you. That fullness can make it easy to imagine the rest of the solar system as similarly occupied. Yet once you step outward in your mind, that feeling falls away. The farther you go, the more the local region opens into great calm stretches where there is almost nothing to see up close at all. Mars is a world. Jupiter is a giant. Saturn carries rings broad enough to astonish anyone who sees them clearly. Yet these planets still sit as isolated presences inside a system where the spaces between them do most of the expanding. That is what makes the solar system feel so strange once the scale becomes honest. It is structured. It is ordered. It is held together by gravity. Yet it is also incredibly sparse. The objects that catch our attention are tiny compared with the region they occupy. Planets that seem important in books and screens become small pieces inside a volume so wide that the emptiness begins to feel like the true landscape. The planets are almost like notes in a much longer silence. And that silence grows as you move outward. The inner planets are separated by large distances. The outer planets sit farther still. Beyond them, the sense of spread increases again. The familiar worlds become fewer, smaller, and more remote. The solar system does not end with a sharp wall. It thins, it stretches, it fades outward into a larger blackness, where sunlight weakens and the sun itself would no longer look like the commanding fire we know from Earth, but like one bright star among others. That thought alone begins to shrink our local world. Because when you finally picture the solar system with its real proportions, Earth does not feel like the center of a rich and crowded arrangement. It feels like one small stop near the inside of an enormous, mostly empty structure. A structure held together by one star and defined far more by its gaps than by its objects. This is one of the most important turns in the whole journey. We often imagine scale by thinking about how big the objects are. Space asks us to think about how big the spaces are. That is where the true size begins to emerge. The emptiness is the measure. The emptiness is the setting. The emptiness is what makes even planets begin to look small. And once that becomes clear, another question rises almost on its own. If our entire planetary system is already this spread out, this sparse, and this easy to lose inside its own distances, then where exactly does this tiny system sit inside the much larger body that contains it? From there, the solar system begins to feel less like the whole story and more like one small part of a much larger map. That larger map is the Milky Way. When you look up into the night sky from Earth, the stars can seem scattered almost at random, as if they are pinned across a flat, dark surface. Some shine brighter than others. Some seem close together. Some stand alone. The sky feels broad, but it does not immediately reveal its structure. It hides the larger shape we are living inside. The Milky Way is that hidden shape. It is the galaxy that contains our sun, our planets, and countless other stars spread across a far greater region than the solar system. The name has been known for a long time because on dark nights, far from city lights, people can see a pale band of light stretching across the sky. That faint glowing band is not a cloud, and it is not a nearby veil of mist. It is the combined light of enormous numbers of distant stars, gathered so thickly along the plane of our galaxy that they blur into a soft river of brightness. We are inside that river. That is why the Milky Way can be hard to picture at first. It is easier to understand the shape of something when you can step outside it. But we cannot step outside the galaxy. We have to build the picture from within, the way someone living inside a forest might slowly realize the forest has edges, patterns, and a larger form they cannot see all at once from the ground. The Milky Way is a spiral galaxy, broad and rotating, with long arms of stars and gas curving outward from a brighter central region. Somewhere inside one of those spiral arm regions sits our solar system, moving along with the rest. We are far from the galactic center. We do not occupy some bright central throne. We are living out in the disk, in a quieter neighborhood, orbiting one ordinary star among many others. That alone changes the feeling of our place. The solar system can seem central when it is the largest structure in view. Once the galaxy appears, our whole planetary home becomes one local address. The sun is still the center of our system, yes. Earth still circles the sun. The moon still circles Earth. But the entire system now belongs to something larger, something with its own motion, its own shape, and its own immense scale. Our cosmic home has an address, and it is more humble than daily life would ever suggest. The sun lies in a spiral arm region often associated with the Orion Arm, a smaller structure between larger arms of the galaxy. We are roughly 26,000 light-years from the galactic center. That number is so wide that it can pass by too quickly, yet it means something very simple in spirit. We are far from the middle. We are out in the suburbs of the galaxy, you could say, circling the center from a distance rather than living close to its crowded heart. And we are moving. Earth moves around the sun. The moon moves around Earth. The galaxy adds another layer to this motion. Our entire solar system is orbiting the center of the Milky Way, carried along through the galaxy over immense stretches of time. One full orbit takes hundreds of millions of years. Human history is so brief by comparison that our species has experienced only a tiny fraction of one galactic year. This can make the whole setting feel strangely alive. The night sky may appear still, yet stillness is only the look of motion happening across distances and timescales too large for ordinary sight. Stars are not simply hanging in place above us. They belong to a galaxy with structure and movement, and we belong to it too. Every day of your life has unfolded inside that larger turning. Once you feel that, the solar system becomes smaller again. It is no longer a great isolated arrangement surrounded by vague darkness. It is one star system embedded in the disk of the Milky Way. One local system, circling quietly, far from the center, surrounded by other stars that also have their own paths, their own planets perhaps, their own distances and silences. Our home remains real and important, yet it starts to feel more like a room within a city than a complete world unto itself. And that thought opens the next door almost immediately. If the solar system is only one address inside the Milky Way, then the galaxy is holding far more than our own small corner. Far more stars, far more neighborhoods, far more places than the eye can count from Earth. So the next question becomes impossible to avoid. How many other addresses are there in this galactic home around us? And once that address comes into view, the sun begins to change with it. From Earth, the sun feels singular. It is the brightest object in our sky, the source of daylight, warmth, weather, growth, and time itself, in the most ordinary sense. Morning begins with it. Seasons depend on it. The color of the sky, the shape of shadows, the rise of plants, the rhythm of sleep and waking, all of it is tied in some way to this one nearby star. A human life can pass under the quiet impression that the sun is something almost beyond comparison. In one sense it is. For us, the sun is everything a star can be. It is the star we know from the inside. It is the one whose light touches our skin, whose gravity holds Earth in orbit, whose energy keeps oceans moving and air circulating. Every other star in the sky arrives as a point of light. The sun arrives as presence. It fills the day so completely that it becomes easy to forget it belongs to the same category as those distant lights overhead. But the galaxy has a way of softening that feeling. Once you step back far enough to place the solar system inside the Milky Way, the sun becomes easier to understand in a larger population. It remains essential to us, yet it stops looking solitary in the cosmic sense. It becomes one star in a structure crowded with stars, one light among an enormous number of other lights, one address in a city so vast that the eye from Earth can only guess at its population. The Milky Way contains roughly 100 to 400 billion stars. Even the smaller end of that range is difficult to absorb. 100 billion is already far beyond what any person can picture as separate individual objects. It is a number that pushes past ordinary counting, past everyday comparison, past the scales our lives are built to hold. When that many stars belong to one galaxy, the sun begins to shift in the mind. It does not shrink physically, it shrinks statistically. That is one of the most powerful changes in this whole journey. The sun is still large compared with Earth. It still contains almost all the mass in our solar system. It still appears overwhelming beside any planet that circles it. Yet inside the Milky Way, it is part of a vast crowd. It is often described as an ordinary star, and that word ordinary can sound almost strange at first. After all, nothing about the sun feels ordinary from the ground. It lights the whole world. It shapes the whole day. Yet ordinary here means something gentle and specific. It means the galaxy contains many stars like this, and many unlike it as well. Larger stars, smaller stars, hotter stars, cooler stars. Stars that burn for shorter lives and stars that endure for far longer. The sun is special to us because it is ours. The galaxy sees it as one star among many. That idea can feel almost impossible at first. The human mind wants to hold on to the sun as central because it is central to our experience. And in our local system, it truly is. Earth circles the sun, not the other way around. Our weather, warmth, and daylight are all ruled by it. Yet once the frame widens to galactic scale, the Sun takes its place inside a much larger census. It becomes one of countless luminous bodies spread through the disk of the Milky Way, and those are only the stars. Around many of them, there may be planets. Around some of those planets, perhaps moons. Around some stars, great belts of rock or gas or dust. Around others, systems very different from our own. The galaxy may be full of local worlds, each centered on its own star the way our life is centered on the Sun. That possibility gives the Milky Way a different kind of depth. It stops feeling like a decorative backdrop and starts to feel inhabited by structure after structure, neighborhood after neighborhood, each separated by distances too large for ordinary life to ever cross. So the Sun remains beloved, familiar, and vital, while becoming less exceptional in the numerical sense. That is the quiet payoff here. Our star does not lose its beauty, it loses its isolation. It becomes part of a population so large that even one galaxy can hold hundreds of billions of fires, each burning in its own corner of the dark. And once that number settles in, another realization begins to rise behind it. If a single galaxy can contain that many stars, then the galaxy itself must be far larger than the Sun's local neighborhood ever prepared us to imagine. It must stretch across a scale where even billions of stars need room to spread out, gather, and move within one shared form. So the next thing we need to feel is the size of the Milky Way itself. From that point on, the galaxy begins to stop feeling like a background and starts feeling like a place with true size. 100 to 400 billion stars already tells us the Milky Way must be enormous. There is no way to hold that many stars inside anything small. Yet numbers of stars alone still leave the galaxy feeling a little abstract, as if it were more of an idea than a structure. To make it feel real, we need a measurement that carries distance and time together. That measurement is one of the most powerful in all of astronomy. The Milky Way is about 100,000 light years across. That sentence sounds clean and simple. The reality inside it is much harder to absorb. A light year is the distance light travels in 1 year, moving at about 300,000 kilometers every second. Light is so fast that it can circle Earth more than 7 times in a single second. It reaches the Moon in a little over 1 second. It reaches the Sun in a little over 8 minutes. In ordinary life, light feels almost instant. It feels like nature's version of no waiting at all. Inside the galaxy, even light has to travel for an immense amount of time. If a beam of light started at one side of the Milky Way and moved straight across to the other, it would need around 100,000 years to finish the trip. That is longer than all of recorded human history several times over. Entire civilizations rise and fade on timescales far smaller than that. Languages change, coastlines shift, species spread, generations appear and disappear, all while one beam of light is still making its way from one edge of our galaxy to the other. That is when the size begins to land. The Milky Way is not simply a wide scatter of stars above our heads. It is a structure so vast that the fastest thing we know still needs a span of time almost too large for the human mind to feel. 100,000 years is a number we can say, but it carries a strange kind of silence with it. It belongs to cave paintings, ice ages, migrations, vanished animals, and worlds of human experience so distant that they already feel half mythical. And that same stretch of time becomes a travel measure inside our own galaxy. This also changes the way our position feels. We already know the solar system sits far from the galactic center, out in one of the spiral arm regions. Now that location begins to gain depth. We are no longer simply inside a galaxy in the general sense. We are inside something with width so immense that local space starts to look microscopic by comparison. The distance from Earth to the Sun, which felt huge earlier, begins to shrink into a local detail. Even the spread of the solar system starts to look like a tiny patch within one star system, inside one region, inside one galaxy, whose full breadth stretches beyond ordinary intuition. And yet, from Earth, the Milky Way still arrives softly. It shows itself as a pale band, a dusting of thicker light across a dark sky. That appearance is part of what makes its true size so astonishing. The galaxy does not announce its scale in a dramatic way to the naked eye. It appears quiet, almost delicate. A faint river overhead, a soft brightness crossing the night. Only later do we learn that this gentle glow is the visible hint of a structure spanning about 100,000 light years. There is something deeply strange and beautiful in that contrast. The biggest structures often enter human awareness in the calmest ways. The Milky Way does not feel heavy from below. It feels distant, silent, and almost fragile. Yet it contains hundreds of billions of stars and stretches across a distance so great that even light needs ages to cross it. The sky above a quiet field can look simple. The reality folded into that simplicity is overwhelming. By now, the galaxy has become more real in two ways at once. It has become real as a population, with hundreds of billions of stars. And it has become real as a span, with a width measured in light years and deep time. That combination matters. It keeps the Milky Way from turning into a decorative word. It becomes a place with scale, motion, neighborhoods, brightness, and immense internal distance. And once that feeling settles in, another thought begins to move forward. If our own galaxy is already this large, this full, and this slow to cross even for light, then what exactly is it in the larger picture of the universe? Is the Milky Way one of the great defining structures of reality? Or is it, in the end, just one more small unit inside something even wider? And with that, the Milky Way begins to change in one more important way. Up to this point, it has grown larger and more impressive each time we widen the frame. First, the solar system became a small local structure inside it. Then the Sun became one ordinary star among its hundreds of billions. Then the galaxy itself took on real size, stretching across about 100,000 light years, wide enough that even light would spend ages crossing it. That already feels immense. A structure that large seems like it should stand near the top of the cosmic ladder. It feels as though once you reach the scale of a galaxy, you must be arriving at something close to final. Something so broad, so filled, and so difficult to cross that there cannot be many things like it. Then the frame widens again. The Milky Way is vast, but it is still only one galaxy. That sentence carries the next great turn in perspective. The galaxy that seemed like a giant city of stars now becomes one member of a much larger population. The shift is similar to what happened when the Sun stopped feeling solitary. Our local star remained important to us while becoming statistically ordinary. Now the same thing happens to the Milky Way. It remains our home galaxy. the only one we know from the inside, the one whose light forms the pale band across our sky. Yet in the wider universe, it is one galaxy among staggering numbers of others. The observable universe likely contains hundreds of billions of galaxies. That number is difficult to hold for the same reason the star count was difficult to hold. Only now the scale is even wider. Each of those galaxies may contain millions, billions, or even trillions of stars. Each may have its own structure, its own history, its own collisions, its own silent neighborhoods of light. And our Milky Way, large as it seemed a moment ago, now sits among them as one example rather than the central case. This is where the universe becomes deeply humbling in a new way. The Milky Way had already reduced the solar system to one address. Now the wider cosmos reduces the Milky Way to one island in a much larger sea. The galaxy does not lose its grandeur. It loses its uniqueness. That is the pattern we keep meeting as the frame expands. A person becomes small against Earth. Earth becomes small against the solar system. The solar system becomes small against the Milky Way. And now, even the Milky Way begins to shrink into one entry in a much greater count. There is something almost quiet about that realization. When people picture the universe, they often picture stars first. Countless stars spread through dark space. But at this scale, stars are no longer the main units of the story. Galaxies are. Each galaxy gathers stars into one larger structure, almost the way a city gathers countless windows into one distant shape. From far enough away, you stop noticing the individual lights and begin seeing the clusters they belong to. That is the scale we are entering now. Our galaxy stops being the main event. It becomes one among many, floating in a universe filled with other galaxies of many kinds. Some are spiral, like the Milky Way. Some are elliptical, rounder and fuller in shape. Some are irregular, less orderly, more unsettled in appearance. Some are smaller. Some are much larger. Some have collided and merged. Some exist in pairs or groups. Some glow with furious star formation. Others are quieter and older. The universe is not built around one perfect example. It is full of versions. And this changes the feeling of home once again. The Milky Way still matters to us because it contains us. That emotional truth remains. But the moment we place it inside a population of hundreds of billions of galaxies, its role becomes more modest. Our galaxy is no longer the great container of reality. It is one container among many, one structure among many, one visible expression of a much broader cosmic order. That thought can almost feel too large to settle, but it also prepares us for something even more surprising. Because once there are hundreds of billions of galaxies, the next question is no longer simply how many there are. The deeper question becomes how they are arranged. Are they spread evenly in all directions like loose grains in a vast dark field? Or do they gather, cluster, and form even larger patterns, the way stars gathered into galaxies before them? If galaxies themselves belong to something bigger, then the universe may still have another level of structure waiting just beyond this one. And once the Milky Way becomes one galaxy among many, the space between galaxies begins to matter in a new way. At first, it is tempting to imagine them scattered everywhere in loose fashion, each one drifting alone through a vast dark, separated from the rest by distance so wide that no larger pattern could really be felt. That picture has a certain beauty to it, a universe filled with island galaxies, each shining on its own. Yet the deeper picture is more connected than that. Galaxies have neighborhoods. The Milky Way does not float through the universe by itself. It belongs to a small collection of galaxies called the local group. This is our immediate galactic neighborhood, the larger community our home galaxy moves within. The name sounds modest, and in a way it is. Local only means local compared with the enormous scales around it. Even this nearby gathering stretches across millions of light years. Inside the local group, the Milky Way is one of the larger members. Another major galaxy here is Andromeda, a great spiral galaxy moving through the same broader region of space. There is also the Triangulum galaxy, smaller than the other two, along with many dwarf galaxies orbiting or traveling near the larger ones. These dwarf galaxies may be faint and small compared with giants like the Milky Way, yet they still belong to the same broader arrangement. They are part of the same neighborhood, the same local web of motion and gravity. That alone changes the feeling of the universe. A galaxy had already become less singular once we understood there are hundreds of billions of them. Now it becomes less solitary as well. The Milky Way is large, full of stars, and grand in its own right. Yet it lives in company. It belongs to a community of galaxies, each with its own structure and history, each moving through shared space under the quiet rule of gravity. Gravity is what makes these neighborhoods possible. Just as the sun gathers planets into a system, and just as a galaxy gathers stars into one larger form, groups of galaxies can remain linked by gravity across much greater distances. The spaces between them are immense, but the connection is still real. Over time, galaxies influence one another. They orbit, drift, draw near, and sometimes even collide and merge. The universe at this level begins to feel less like a random spread of lights and more like a layered structure, with smaller systems nested inside larger ones. The local group gives us our first clear view of that layered order. Our galaxy is one home. The local group is the neighborhood around that home. It is the region where the Milky Way and nearby galaxies belong together in one larger gravitational setting. That does not make them crowded in any ordinary sense. The emptiness between galaxies remains enormous. Yet there is still a pattern now, a shape to the arrangement, a sense that galaxies gather rather than simply appearing anywhere at random. And even within this neighborhood, motion continues. The Milky Way and Andromeda are moving toward one another and are expected, over immense spans of time, to merge in the distant future. That fact adds something almost startling to the calmness of the night sky. The galaxy above us feels fixed and ancient, yet it belongs to a neighborhood that is still changing. The larger structures of the universe are not frozen ornaments. They live through motion, influence, and time. Once you feel that, the universe begins to take on a different kind of meaning. Earlier, the great widening of scale made things feel smaller by turning them into members of larger populations. Here, the widening does something slightly different. It begins to reveal organization. Galaxies are many, yes, but they also gather. They form families, neighborhoods, and linked regions. A galaxy is no longer just an isolated island of stars. It is part of a broader arrangement that extends beyond its own edges. That makes the universe feel less random and more architectural. The same pattern keeps returning. Moons gather around planets. Planets gather around stars. Stars gather into galaxies. Galaxies gather into groups. Each level widens the frame while also revealing a deeper order within it. The farther out we go, the more the cosmos begins to resemble a structure built in layers, with each layer containing smaller ones inside it. And that thought leads naturally onward. Because if even galaxies gather into neighborhoods like the local group, then those neighborhoods may also belong to larger communities still. There may be bigger patterns waiting beyond our immediate galactic surroundings, structures so wide that even a group of galaxies becomes only one small part of something larger. From there, the pattern keeps opening. A galaxy group like the local group already gives the universe more shape than the night sky first suggests. The Milky Way belongs somewhere. Andromeda belongs somewhere. Smaller galaxies gather around larger ones. Gravity keeps drawing structures together into neighborhoods and communities. That alone makes the cosmos feel more ordered than a simple field of scattered lights. But the order does not stop there. When astronomers look much farther out, across enormous reaches of space, they find that galaxies and galaxy clusters are arranged in patterns on scales so vast that the mind has to widen once again. The universe has structure at giant scale. It is not a smooth, even spread of matter in every direction. It has thick regions, thin regions, long connected strands, and enormous openings between them. This larger pattern is often called the cosmic web. It is a beautiful name, and also a very useful one, because it captures the shape surprisingly well. If you could step far enough away to see great stretches of the visible universe at once, you would find that galaxies are not sprinkled evenly like dust across a floor. They gather into filaments, which are long thread-like regions containing galaxies and clusters. These filaments meet at denser knots, where matter has collected more heavily, and between them lie vast voids, regions where far fewer galaxies are found. So the universe, on its largest visible scales, begins to look less like a random cloud and more like a web. That idea can feel strange at first, because we are so used to thinking about individual objects. A person, a planet, a star, a galaxy. Each one feels like its own thing. The cosmic web asks us to think in terms of patterns that only appear when the frame becomes enormous. A single galaxy is one point inside that pattern. A galaxy group is one local feature. A cluster is one denser gathering. But the web itself is what emerges when all of them are seen together. And just as important as the filaments are the voids. Voids are not tiny empty pockets. They are vast regions of space with far fewer galaxies than the filaments and clusters around them. This gives the universe an even more dramatic shape. Matter has gathered along certain large-scale routes, while other huge regions remain comparatively sparse. The emptiness we first felt inside the solar system returns here in a new form, much larger and far more profound. Space contains objects, yes, but it also contains immense absences, and those absences help define the whole structure. This is one of the quietest and most astonishing turns in the journey. The universe is not only large, it is organized. That does not mean it is arranged with neat human symmetry. It does not look like a machine built from straight lines and perfect circles. Its order is more organic than that, more like branching growth, tension, and flow. Matter gathered over immense spans of time under gravity, slowly tracing out these larger forms. The result is a cosmos with architecture, though it is an architecture shaped by natural laws rather than intention. And that makes our place feel different again. The Milky Way is still our home galaxy. The local group is still our neighborhood. But now, both are small features inside a much wider design. Our galaxy group belongs somewhere inside this larger web of filaments and emptier regions. The scale has become so great that even galaxy clusters begin to feel like local details. The universe keeps doing this. Each time something seems large enough to be final, it becomes part of a larger arrangement. There is something deeply calming in that rhythm. The cosmos keeps widening, but it does so with pattern. It does so with structure. The larger it becomes, the more it reveals that size and shape are growing together. We are not drifting through featureless vastness. We are living inside a universe where matter has gathered into stars, stars into galaxies, galaxies into groups, and groups into enormous web-like structures stretching across unimaginable distances. By now, the visible universe already feels almost too wide to hold. Yet even here, another question begins to rise naturally. If the universe stretches into filaments, clusters, and voids on scales this great, then how far does our vision actually reach? At what point do we arrive at the edge of what light has had time to show us? And that is where the next kind of boundary appears. Up to this point, the universe has kept growing by widening the frame. The solar system opened into the Milky Way. The Milky Way opened into a universe filled with other galaxies. Those galaxies gathered into groups, clusters, filaments, and vast voids. Each step made the visible cosmos feel larger, deeper, and more richly structured. Then, a quieter realization begins to enter. However far the universe may truly extend, there is only a certain portion of it we can actually see. That limit exists for a simple reason, though its consequences are enormous. Light does not travel infinitely fast. It moves at a finite speed, about 300,000 kilometers per second. That speed is extraordinary by human standards. It can cross Earth more than 7 times in 1 second. It reaches the moon in a little over a second. It reaches the sun in a little over 8 minutes. Earlier, we saw that even light needs about 100,000 years to cross the Milky Way. Now that same fact begins to shape the whole universe. When we look into space, we are also looking into time. Light from distant places takes time to reach us, and the farther away something is, the longer its light has been traveling. A nearby object may be seen almost as it is now. A more distant star may be seen as it was years ago. A distant galaxy may be seen as it was millions or billions of years in the past. The night sky is full of delayed arrival. It is a record of light still making its way toward us. That means vision has a horizon. The universe has a finite age, about 13.8 billion years. So there has only been a certain amount of time for light to travel since the beginning of the cosmos as we understand it. If some region lies so far away that its light has not had enough time to reach Earth yet, then that region remains beyond our view. It may exist. It may be full of galaxies, structure, and history, but it is outside the part of reality we can directly observe. This is what astronomers mean by the observable universe. It is the region of the cosmos from which light has had time to arrive here since the beginning. That does not mean it is the whole universe. It means it is the visible portion, the part placed within our reach by time and light together. Beyond that lies a larger question, and perhaps a larger reality, yet the edge of our direct seeing is already built into the story. That edge is not like a wall floating in space. There is no great glowing shell where the universe suddenly stops. The limit is tied to observation itself. It is a horizon in the deepest sense, formed by the age of the universe and the finite speed of light. In some ways, it is similar to standing on Earth and seeing only so far because of the curve of the planet. The world continues beyond what your eyes can reach, yet your view still has an edge. Here, though, the scale is vastly greater, and the horizon is shaped by cosmic time. This changes the feeling of knowing. The universe already felt humbling because of its size. Now it becomes humbling in another way. There is a built-in limit to what any observer can see from any one place. Even with perfect instruments, there is still a horizon set by light and time. The cosmos is wide, but our window into it is finite. That truth gives the observable universe a special kind of beauty. Everything we study in deep space belongs to the part of reality that has had time to reveal itself to us. And yet, even this limited window is astonishingly vast. Within it lie hundreds of billions of galaxies, giant filaments, immense voids, and light that has traveled for unimaginable lengths of time. The observable universe is already far beyond anything early human beings could have guessed when they looked up into the dark. It is more than enough to fill the mind with wonder. Still, the idea of a horizon leaves one more question suspended in the air. If our view ends at an observable limit, then how large is that visible region itself? How wide is the portion of the universe that light has actually allowed us to see? That visible horizon already feels immense the moment it enters the story. A universe with a limit to what we can observe is humbling enough on its own. It means there are places whose light has had time to reach us, and places whose light has not. It means our view of reality, however wide it may become, still arrives through a finite window. Yet the next surprise is even stranger, because when astronomers measure the size of that visible region, the answer sounds almost impossible at first. The observable universe is about 93 billion light-years across. It is one of those numbers that can make the mind pause for a moment, almost as if it misheard. Earlier, we said the universe is about 13.8 billion years old. If light travels 1 light-year in a year, then a first guess might sound simple enough. Perhaps the visible universe should be around 13.8 billion light-years in every direction, or about 27.6 billion light-years across from one side to the other. That sounds reasonable. And yet the actual number is much larger. About 93 billion light-years across. This is where cosmic scale stops feeling merely large and starts feeling truly difficult. The number does not just stretch the imagination. It seems to resist it. A visible universe 93 billion light-years wide means the region we can observe is far broader than the age of the universe, multiplied by light speed in the simplest way would seem to allow. So before we even explain why that is true, it helps to sit with what the number itself means. Picture all the distances we have already crossed in thought. A person disappearing against Earth, Earth shrinking beside the moon and sun, the solar system spreading into long emptiness, the Milky Way widening to about 100,000 light-years across, then our galaxy becoming one among hundreds of billions of galaxies, then those galaxies gathering into groups, clusters, filaments, and voids. All of that still belongs to the visible region whose full width reaches about 93 billion light-years. That means the observable universe is wide enough to contain every galaxy we have ever detected, every distant cluster whose light finally found its way here, every filament of the cosmic web, every ancient signal arriving from deep time, all within one vast region whose breadth is measured in tens of billions of light years. And even that is only the part we can see. There is something deeply strange in that thought. The visible universe already feels too large to hold, yet it may still be only the revealed portion, the part whose light has had time to arrive. The number 93 billion light-years does not describe all that exists. It describes the size of the window. That alone gives the universe a different emotional shape. The observable cosmos is not a small bubble around us in any ordinary sense. It is not a narrow lantern beam cutting through a much larger dark. It is already staggeringly vast, so vast that galaxies themselves become the small units inside it. To call it a horizon can make it sound near. In truth, this horizon encloses a region of such breadth that even language begins to thin out around it. This is one of the most satisfying turns in the whole journey, because at last the visible universe receives a concrete scale anchor. It is no longer just the idea of a limit. It is a measurable region with a real width, a cosmic span that can be stated plainly, even if it takes time for the mind to absorb. About 93 billion light-years across. That number becomes a kind of marker in the dark, something firm enough to return to as the wider picture keeps unfolding. And still, the number leaves behind a tension of its own. Because if the universe is about 13.8 billion years old, then how can the observable part be so much wider than 27.6 billion light-years? How can light, traveling for a finite amount of time, reveal a region whose present width seems to outrun the simplest version of the math? The answer lies in something even stranger than distance alone. It lies in the fact that space itself has not been sitting still while the light was on its way. That is the point where the universe asks us to let go of one more ordinary instinct. Most of the time, we imagine distance as something fixed. A road stays the same length, whether you walk it today or next week. A room keeps the same width while you stand inside it. A field does not quietly stretch while you cross it. In daily life, space feels like a stable stage where things simply move around. The universe does something stranger than that. On the larger scales, space itself expands. The galaxies are not all racing outward through a pre-existing empty container, the way sparks fly away from a firework. The deeper picture is that the fabric of space between distant galaxies has been stretching over time. That means the stage is changing while the actors are on it. Once that idea enters the story, the earlier number begins to make more sense. The universe is about 13.8 billion years old. So at first glance, it seems natural to think the most distant light we can see should come from places about 13.8 billion light-years away. But while that light was traveling toward us for billions of years, the space between us and its source did not stay frozen. It expanded. The light kept coming, and the universe kept stretching. So the place that sent the light long ago is much farther away now than it was when the light began its journey. That is why the observable universe can be about 93 billion light-years across. The light has indeed been traveling for a finite amount of time, but the present-day distance to the farthest visible regions has grown during that journey. The visible universe is larger than a simple 1 year equals 1 light-year calculation would suggest, because the space inside the calculation has been changing all along. A helpful way to picture this is to imagine small dots drawn on the surface of a balloon. As the balloon inflates, the dots move farther apart, even though they are not crawling across the surface under their own power. The surface itself is stretching. In a loose and limited way, that can help the mind picture cosmic expansion. Galaxies on the largest scales become more separated over time because space between them grows. This does not mean everything everywhere is expanding away from everything else in the same direct sense. Smaller bound systems hold together through gravity and other forces. The solar system is not being pulled apart by cosmic expansion in any noticeable everyday way. The Milky Way is not dissolving because of it. Your room is not slowly swelling while you listen. Expansion matters most across the truly enormous scales between great cosmic structures, where gravity does not keep everything gathered tightly enough to resist that broader stretching. That distinction matters because it keeps the picture clear. The universe is changing at the largest scales, while many smaller structures inside it remain locally bound. Galaxies can stay galaxies. Star systems can stay star systems. Planets can keep orbiting stars. Yet across the wide gulf between distant clusters and superclusters, space itself continues to stretch, gradually increasing the separations. This changes the feeling of distance in a profound way. A distant galaxy is not just far in the ordinary sense. It is part of a universe whose geometry has evolved while its light was crossing the dark. Looking deep into space means looking into a history where distance itself has been alive, shifting, and growing. The farther we look, the more we are seeing light that began its journey in a younger cosmos, one where the large-scale spacing of things was different from what it is now. That gives the universe a softer, more fluid character than people often imagine. It is easy to picture the cosmos as a giant frozen arrangement, with galaxies sitting in fixed places like decorations on a ceiling. The real universe is more dynamic than that. It has a history written into its spacing. It has grown while light traveled through it. The emptiness between distant places has its own story. And once that settles into place, the earlier contradiction stops feeling like a contradiction at all. The number 93 billion light-years no longer sounds like a mistake. It sounds like the natural result of a universe whose scale has been unfolding over time. The visible cosmos is wide because space has stretched, while ancient light kept moving through it toward us. Which leads to the next quiet question. If space itself expands across the largest scales, then what does that mean for the future shape of the universe? What happens to distant galaxies and to the visibility of the cosmos as that stretching continues? And once expansion becomes real, another consequence begins to emerge from it very quietly. Distance in the universe is not only large, in many cases it is growing. The great separations between faraway galaxies are increasing over time because space itself continues to stretch. That already changes the way the cosmos feels. But there is something deeper inside it, something more personal to the act of seeing. Parts of the universe are becoming harder to reach with light. That idea takes a moment to settle in, because light feels like the closest thing nature has to perfect speed. It crosses Earth in a fraction of a second. It moves from the moon to us in a little over 1 second. It reaches us from the sun in a little over 8 minutes. Even across the Milky Way, where the scale becomes enormous, light still remains the standard by which all distance is measured. Yet across the very largest scales, expansion changes the story. When galaxies are extremely far away, the space between them and us can grow so rapidly over time that their light has a harder and harder task. It is still moving toward us locally at the speed of light, but the stretching of space changes the larger picture. The result is that some distant regions are effectively being carried away from us in a way that makes them less accessible to observation as time goes on. This gives expansion a consequence the mind can feel. The universe is not only wide, it is becoming more isolated. That does not mean nearby galaxies are all slipping out of reach at once. Our local neighborhood remains bound together in important ways. The Milky Way and Andromeda, for example, are moving toward one another, held within the same broader gravitational region. Smaller local structures can remain connected, but beyond those nearby scales, the general expansion of the universe keeps opening the gaps wider. So if you imagine observers living in the far future, their visible cosmos may be poorer in some ways than ours. They may still see their local bound galaxies. They may still have stars, planets, and the immediate structures around them. But many of the distant galaxies we can observe today could become so redshifted, so faint, and so remote in the expanding universe that they would no longer be visible in the same way. The larger cosmic landscape could slowly fade from practical reach. That is a strange thing to realize. We often think of knowledge as something that only increases. Learn more, build better tools, look farther, gather more of reality into view. And that has been true in many ways. Human beings have extended their sight from the nearby world to the moon, the planets, the stars, the galaxies, and the deep structure of the cosmos. Yet the universe itself places limits on what any era can see. There are features of the present cosmic view that belong to this chapter of cosmic history. In that sense, we live at a fortunate time for observation. The distant universe is still visible to us in ways that may not remain equally visible forever. Ancient light continues to arrive. Remote galaxies still leave their traces in our instruments. The large-scale structure of the cosmos can still be studied because enough of it remains within our reach as observers. Expansion has not erased that view, though it is carrying parts of the universe farther away all the time. So expansion becomes more than a technical fact. It becomes a kind of quiet thinning. The visible universe still holds astonishing richness, but its most distant parts are tied to a moving boundary. The farther out we look, the more delicate the act of seeing becomes. Light from remote regions has to cross a universe that has been stretching the whole time, and that stretching shapes what can arrive, what can remain visible, and what may someday slip beyond any future horizon of observation. There is something almost melancholy in that, though calm as well. The cosmos is giving us a view, and that view is immense. But it is also temporary in certain ways. The largest scales are not simply sitting there, waiting forever in the same form. The universe is evolving. Its distances are changing. Its visibility has a history and a future. And once visibility itself can shrink, another deeper thought begins to form. If there are already parts of reality becoming less reachable over time, then perhaps there are also parts of reality that were never reachable to begin with. Regions beyond any light we could ever receive, beyond any instrument, beyond any direct seeing. Which raises the next question in the quietest possible way. how much of the universe may always remain outside our window entirely. From there, the boundary becomes even more unsettling in a calm and quiet way. We have already reached the edge of what light has had time to show us. We have already seen that the observable universe is vast beyond ordinary feeling, and that even this visible portion is shaped by time, expansion, and distance. That alone is enough to leave the human mind standing in awe. Yet the next thought carries us one step farther still. The part we can observe may be only a portion of what exists. That idea grows naturally from everything we have already seen. The observable universe is defined by a horizon. It is the region from which light has had enough time to reach us since the beginning of the universe as we understand it. That is a limit on our view. It is not necessarily a limit on reality itself. The edge of observation and the edge of existence are two very different things. This matters deeply. When you stand on Earth and look toward the horizon, you see the limit of your sight, not the end of the planet. The land continues beyond what your eyes can hold from that spot. In a much larger and stranger way, the observable universe may work like that. Our vision reaches a certain distance because of light and time, while reality may continue far beyond that visible boundary. Modern cosmology leaves room for exactly this possibility. The universe beyond our observable horizon may extend much farther than we can ever directly see. It may be enormously larger than the visible region around us. It may even be so much larger that the entire observable universe, large as it feels, becomes one local patch inside something far wider. That wider whole may share the same general laws and structure we know, or it may contain features we cannot test directly from here. What matters most for this moment is simpler. The visible universe may be only the beginning. This is the deepest scale boundary we have reached so far. Earlier, we widened the frame and watched one thing after another lose its feeling of finality. A person became small against Earth. Earth became small against the solar system. The solar system became small inside the Milky Way. The Milky Way became one galaxy among hundreds of billions. The observable universe then appeared as the great visible stage containing all of those structures. For a moment, that could feel close to final again. Then this thought arrives and gently opens the frame once more. Even the observable universe may be local. That sentence is almost too large to feel all at once. The visible cosmos already holds ancient galaxies, vast filaments, immense voids, and light that has traveled for billions of years. To imagine that all of that may still belong to one limited patch of a much larger whole is to arrive at a scale where the human mind can no longer build a full picture. At this edge, understanding becomes more about accepting the shape of the idea than seeing the whole thing clearly. And that is all right. There is a kind of honesty in reaching a point where the universe becomes larger than imagination can cleanly contain. The goal here is not to force the mind to see the full unseeable thing. The goal is to feel the direction of the truth. The horizon of observation is real. The wider reality beyond it may also be real. And the difference between those two is one of the most humbling ideas in all of science. It changes the meaning of what we call the universe in ordinary speech. Sometimes people use the word universe to mean everything that exists. Other times, they mean the observable universe, the part we can actually study through incoming light and other signals. These are related ideas, but they are not automatically the same thing. The part available to observation may be only one fraction of the whole, a fraction so vast that it already contains more galaxies than any human being could ever count, yet still perhaps only a partial glimpse. There is something both unsettling and beautiful in that. Unsettling, because it reminds us that knowledge has limits built into it. Beautiful, because it reveals reality as richer than our direct access to it. The universe is wide enough to give us wonder within the visible part alone, and wide enough perhaps to extend beyond every horizon we can name. By now, the scale has become almost too large to speak of in ordinary emotional terms. And that is exactly why the next turn matters. Because once the visible universe itself may be only one patch in something much greater, the question is no longer only about distance. It becomes about us, about what this does to the human sense of place, about how a creature living on one small planet is meant to feel after learning that even the largest visible structures may still be local in the grandest sense. And after all of that widening, something very quiet begins to happen. The frame has opened so far that the universe no longer feels like a distant subject. It begins to bend back toward ordinary life. The galaxies, the cosmic web, the observable horizon, even the thought that the visible universe may be only one patch of something greater, all of it slowly turns the mind toward a simpler question. What does this make a human life feel like? By now, the scale is almost too large to carry in one piece. The observable universe stretches about 93 billion light-years across. Our galaxy is one among hundreds of billions. Our Sun is one star among hundreds of billions inside that galaxy. Earth is one planet circling that one star. And on Earth, each of us lives out a life measured in decades. That contrast is difficult to ignore once it fully settles in. A human life is brief even on human terms. Childhood passes, faces change, homes change. Years that once felt slow begin to move faster. A person may live 70, 80, or 90 years if they are fortunate. Some lives are much shorter. Even a long human life, when set beside the age of civilizations, can feel quick. When placed beside the history of Earth, it becomes very brief indeed. And when placed beside stars, galaxies, and cosmic time, it becomes something even smaller than brief. It becomes almost like a flash of awareness passing across the surface of one tiny world. Yet that flash contains everything a person knows. That is part of what makes this realization so powerful. A human life is small in duration and small in physical scale. Yet from the inside, it does not feel small at all. A single afternoon can feel full. A single loss can feel enormous. Waiting 1 hour for news can feel longer than a year once felt in childhood. A room can feel heavy with memory. A conversation can shape the rest of a life. Human experience is physically tiny and emotionally immense at the same time. The universe does not erase that. It places it. You live on a planet that would disappear from view beside the distances around it. That planet circles one ordinary star in one ordinary region of one galaxy. That galaxy belongs to a visible universe so wide that the numbers themselves begin to thin out in the mind. And inside all of that, one person wakes up, speaks, worries, laughs, remembers, hopes, and eventually is gone. There is something almost startling in how both of those truths can sit together so calmly. A human being is very small in the cosmic sense. That is simply part of the picture now. The widening frame has made that impossible to deny. Yet human life is also the place where the whole picture becomes meaningful at all. The stars do not become vast on their own. Vastness is something felt by a conscious mind. Distance becomes wonder only when someone is there to wonder at it. This is where the journey shifts. Earlier, the widening of the frame kept shrinking the things inside it. A person vanished against Earth. Earth shrank against the solar system. The solar system became one address inside the Milky Way. The Milky Way became one galaxy among countless others. The observable universe itself may be only one visible patch of something larger still. That movement taught us scale. Now it begins to teach us perspective. Because once you feel how physically small a human life is, the next question rises almost by itself. Does small in size mean small in meaning? Does brief in duration mean brief in value? Does living on one tiny planet in one tiny system make a life somehow lesser? Or does meaning belong to a different kind of measure entirely? That is where the cosmic picture becomes deeply personal. It no longer matters only that the universe is large. It matters that beings as small as we are can know that largeness, feel it, and be changed by it. The scale of the cosmos can make human life feel fragile, temporary, and local. But it can also make it feel precious. A short life inside an immense universe is still a life. A brief awareness inside cosmic time is still awareness. The frame has grown larger than we ever live within directly. Yet the simple fact of being here to notice it remains quietly extraordinary. And that brings us to the next thought, waiting in the dark. If our lives are physically small beyond question, does that smallness also decide what they are worth? Or are size and meaning two very different things? That question lingers because the human heart hears size in more than one way. By now, physical smallness is no longer something we can avoid. The journey has made it plain. We live on a tiny planet, around one ordinary star in one galaxy, among hundreds of billions. Our lives are short beside cosmic time. Our bodies are small beside almost every structure the universe contains, measured by distance, mass, and duration. We are modest in nearly every direction. And yet, something inside us resists the idea that small must also mean slight. That resistance comes from experience. It comes from life as it is actually lived. A memory takes up almost no physical space. You cannot weigh it in any meaningful way. You cannot hold it in your hands. Yet one memory can shape the feeling of an entire decade. A voice occupies a little moving air, gone almost as soon as it is spoken. Yet one voice can calm a frightened child, break a silence, carry love, or stay with someone for years after the speaker is gone. A relationship exists in meetings, words, gestures, shared time, and invisible trust. It does not fill a stadium. It does not shine like a star. Yet for the person living inside it, it can become one of the largest things in life. This is where size and meaning begin to separate. The universe measures one kind of largeness very well. It measures width, age, brightness, gravity, mass, distance, speed. These are real and powerful measures. They help us understand stars, galaxies, and the great structures of the cosmos. But lived experience uses another measure as well. Importance in a human life is often carried by things that are physically delicate, brief, or hard to point to at all. A promise is small in sound. A photograph is small in size. A goodbye is small in duration. A single evening can be small in time. And yet, each of these can become enormous within a person's life. That does not make cosmic scale less real. It simply reveals that physical extent and human value are different kinds of truth. One tells us how large something is in space. The other tells us how deeply it enters a life. A star can be huge and personally distant. A sentence can be tiny and personally life-changing. A planet can outweigh every building on Earth. A handwritten note can outweigh a year in the mind of the person who receives it. This changes the emotional meaning of everything we have seen. Earlier, each widening frame seemed to shrink us. A person vanished against Earth. Earth shrank into the solar system. The solar system shrank into the galaxy. The galaxy became one among countless others. That progression could leave the impression that every widening step makes human life less important. But that conclusion does not actually follow from the scale itself. It only follows if size is allowed to decide every other form of value. Life suggests something gentler. Human beings have always known, even without saying it this way, that the most important parts of life often arrive in small forms. A child falling asleep on a shoulder, a familiar laugh from another room, the face of someone waiting for you, a few words spoken at the right moment, a quiet morning in a kitchen, the memory of being loved. These things take up almost no room in the universe. They do not register against galaxies. Yet inside a life, they can become central. So smallness begins to change meaning here. Small can still mean fragile. Small can still mean local. Small can still mean brief. But small no longer means empty. Small no longer means trivial. In fact, many of the things human beings protect most carefully are small exactly because they are vulnerable and deeply felt. Their importance does not come from taking up more space. It comes from the kind of presence they have within awareness, memory, and relationship. There is relief in that. The cosmos remains vast. We remain tiny within it by every physical measure we have explored. Nothing in this section takes that away. But the emotional pressure of that fact softens once we see that meaning lives by a different rule. A life does not have to be large in distance to be large in experience. A person does not have to be cosmically central to be deeply significant within the world they touch. And once that becomes clear, another question rises in a quieter, more beautiful form. If meaning does not come from size alone, then perhaps the most remarkable thing about our tiny place in the universe is not merely that we are small, but that beings this small can feel, remember, love, wonder, and understand at all. And that may be the most surprising turn of all. After everything we have seen, it would be easy to stop at humility. A human being is small. Earth is small. The solar system is a small local structure. The Milky Way is one galaxy among hundreds of billions. Even the observable universe may be only one visible patch of something wider still. That picture already carries enough scale to quiet the mind for a long time. Yet there is another fact moving quietly beside it. Beings this small have learned to measure the whole. That sentence may sound simple at first, though it holds something extraordinary. Human beings are tiny creatures living on the surface of one planet. We do not stand outside the universe to inspect it. We do not hover above galaxies and trace their shapes with our hands. We live at ground level, inside weather, gravity, seasons, hunger, memory, and passing years. And still, from that small position, we have learned to reach outward with thought. We learned that Earth is a sphere turning through space. We learned the distance to the moon. We learned that the sun is a star. We learned that the stars are far away, and then much farther than early people ever imagined. We learned that the Milky Way is a galaxy, that galaxies move, that the universe expands, that light carries age within it, and that the visible cosmos has a history stretching back billions of years. Tiny beings, on one small world, piece together a map of things vastly larger than themselves. That alone deserves a moment of stillness. The cosmos did not arrive as one neat answer. It came in fragments. A moving point in the sky, a changing season, a pattern of stars, a strange shift in light, a faint signal in a telescope, a curve in data, a repeated law. One generation noticed something. Another measured it more carefully. Another found a better tool. Over time, piece by piece, the human species built an understanding of a universe no single person could ever see all at once. There is something deeply beautiful in that. A child can look up at the night sky and feel wonder without knowing the numbers. A scientist can spend a lifetime refining those numbers and still feel the same wonder in a different form. Somewhere between those two experiences lies one of the most remarkable truths about us. We are small enough to vanish against the Earth, yet aware enough to discover the scale of galaxies. We are brief enough to live only a few decades, yet thoughtful enough to reconstruct billions of years of cosmic history. The universe becomes meaningful through that meeting. Stars burn whether anyone sees them or not. Galaxies turn whether anyone measures them or not. Light travels whether anyone understands it or not. Yet once awareness appears, something changes in the texture of reality. Distance becomes knowledge. Motion becomes pattern. Time becomes story. The cosmos does not become larger because we understand it, but it does become more deeply felt. And that feeling belongs to creatures who are, in every physical way, astonishingly small. This is why our smallness and our greatness are able to sit together so calmly. Physically, we are tiny. Intellectually, we have reached far. Emotionally, we can hold both truths at once. We can feel humbled by scale and enlarged by understanding. We can stand on one world, under one sky, and slowly discover that we are part of a universe far wider than any instinct would ever prepare us for. That is a rare kind of achievement. Human beings have measured the distances to stars. We have tracked the motion of galaxies. We have studied the afterglow of the early universe. We have learned that the cosmos has structure, age, expansion, and horizons. None of this changes the fact that we are small. It changes the meaning of being small. It suggests that awareness itself is one of the most unusual things in the picture. A tiny species on a tiny planet learned to notice the shape of the vast. That may be one of the quiet wonders of existence. Yet even that wonder carries its own fragility. Awareness feels immense from the inside, though it rests on delicate conditions. A living body, a stable world, time enough to learn, peace enough to think, light enough to see, memory enough to connect one idea to another. Once that becomes clear, the next thought rises very gently. If consciousness is part of what makes our tiny place in the universe so remarkable, then it may also be one of the most fragile things we know. And that is where the wonder begins to feel delicate. A tiny species on a tiny world has learned to notice the age, scale, and structure of the universe. That already feels extraordinary. Yet the ability to notice any of it at all rests on conditions far narrower than daily life usually makes us feel. Awareness can seem strong from the inside. Human life can feel steady while we are living it. The ground appears firm. The sky feels normal. Breathing feels automatic. Water comes from a tap. Warmth can be found indoors. Morning follows night so reliably that it begins to seem almost guaranteed. The wider universe tells a different story. Life, at least the kind we know, depends on a surprisingly thin margin. It depends on many things staying within a range narrow enough to be easy to overlook. The atmosphere around Earth is one of them. From the ground, the sky feels huge. It arches above fields, oceans, mountains, and cities with an almost endless presence. Yet the breathable part of that sky is only a thin layer wrapped around the planet. Compared with Earth as a whole, the part that supports human life is delicate, shallow, and easily disturbed. That thinness matters. So does temperature. Human beings live comfortably only within a narrow band compared with the extremes the universe allows. A little too cold, and life begins to struggle. A little too hot, and it struggles again. Earth holds liquid water across much of its surface because the planet sits in a range where water can remain liquid over long spans of time. That fact sounds ordinary because it is familiar. In reality, it is one of the quiet foundations beneath everything we do. Liquid water matters because life as we know it depends on it. So does long-term stability. Earth has had time. Time for oceans to persist, for chemistry to build complexity, for living things to change over ages, for minds to emerge slowly from simpler beginnings. Human consciousness did not appear in a moment. It arrived after an immense chain of survival, adaptation, chance, and continuity. Generations lived and died before any creature on this world could look up and understand even a little of where it was. This makes awareness feel both precious and precarious. Conscious life depends on a planet staying hospitable long enough for complexity to grow. It depends on energy from a stable star. It depends on gravity strong enough to hold an atmosphere, but gentle enough to allow movement and life at the surface. It depends on chemistry, water, shelter from the harshest radiation, and a long continuity of conditions that do not collapse too quickly. From far away, Earth is a small sphere. From close up, it is a narrow zone where countless balances happen at once. Our survival turns out to rest on a very thin margin. That does not mean life is weak in spirit. Life is persistent, adaptable, and inventive. It has filled seas, forests, deserts, and skies. It has survived impacts, ice, drought, heat, and upheaval. Yet even that persistence unfolds inside a larger truth. The conditions that allow life to flourish are not spread evenly through the universe like some broad blanket. They appear to be specific, local, and dependent on many layers holding together. The same is true of consciousness. A thinking mind feels immense from the inside because it contains memory, fear, love, language, curiosity, and the ability to imagine things beyond immediate survival. Yet that rich inner world rests on a body, and that body rests on a biosphere. And that biosphere rests on a world, and that world rests within a narrow zone of conditions that have remained livable across deep time. The chain is long, the margin is thin. The result is astonishing. This changes the feeling of human uniqueness. We are not only small in a large universe, we are also fragile in a universe full of extremes. Airlessness, cold, heat, radiation, pressure, emptiness, and distance seem to be far more common than the stable comforts we wake up inside each day. The ordinary world of breath, water, warmth, and long continuity begins to look less ordinary once the wider setting is understood. And once that becomes clear, the next feeling arrives almost on its own. If life, thought, and awareness depend on such a narrow band of favorable conditions, then Earth begins to look different as well. Less like a default setting, more like a small shelter held within an immense and difficult cosmos. A tiny world, physically modest, yet carrying one of the rarest and most delicate things we know. And with that, Earth begins to change one final time. For most of this journey, each widening step made our home feel smaller. First, it became a globe instead of a ground. Then a planet beside the moon and sun. Then one world inside a solar system, mostly made of emptiness. Then one tiny part of one galaxy among hundreds of billions. By every physical measure we have followed, Earth is small. That truth remains. The widening frame has made it steady and clear. Yet another truth begins to rise beside it now. Earth may be small in the cosmos, but it is immense in meaning. That meaning does not come from size, brightness, or central position. It comes from what this world holds. Every human story has happened here. Every language first formed in voices on this planet. Every piece of music, every painting, every prayer, every argument, every promise, every act of care, every invention, every mistake, every war, every reconciliation, every childhood, every funeral, every poem, every scientific discovery, every laugh shared across a table, every memory anyone has ever carried, all of it has unfolded on this one small world. That is an astonishing thing to pause with. From far away, Earth is a tiny sphere. From within, it contains everything we know directly that matters to us. Not one part of it, all of it. The entire human world, with all its beauty and sorrow, has lived inside the thin atmosphere and small surface of this planet. Every empire rose here. Every family began here. Every person who ever looked up and wondered where they were did so from here. This gives Earth a different kind of scale. Earlier, physical scale was the measure. How wide something is, how long it takes light to cross it, how many stars it contains, how many galaxies exist beyond it. Those measures are still true, and they matter. But Earth now returns with another kind of largeness, one that belongs to experience rather than distance. It is small in the geometry of the universe, yet vast in the density of what has been lived upon it. A single library can hold thousands of lives in books. A single city can hold millions of private worlds. A single human face can carry years of memory. Earth holds all of that, and much more. This is why the planet begins to feel precious in a deeper way once the cosmic frame is understood. It is physically ordinary in some respects, one rocky world around one ordinary star. Yet for us, it is the place where awareness blossomed into language, where curiosity became science, where fear and love and art and history added into one long human story. We do not need Earth to be cosmically large for it to be immeasurably important. In fact, its smallness may be part of what sharpens that importance. A shelter is meaningful because it holds life within vulnerability. A home matters because it protects what is fragile and irreplaceable. Earth is like that on the largest scale we know personally. A small shelter in a vast surrounding dark. A world carrying oceans, forests, deserts, cities, animals, memory, and thought, all within a universe that seems, in so many places, cold, silent, and extreme. That contrast restores something gentle. The earlier sections taught humility. Earth shrank. Humanity shrank. Our local world became one tiny place within structures so large they almost dissolved ordinary feeling. Here, that same Earth returns without regaining physical size. It stays small in the cosmic sense, but emotionally, it becomes enormous again, because it contains the only life, history, and consciousness we know firsthand. The smallest shelter becomes the most meaningful place. And perhaps that is one of the calmest truths in the whole journey. We do not need to be at the center of the universe for this world to matter completely to us. We do not need Earth to be the largest thing for it to hold the largest share of what we love. A planet can be tiny in space and still carry everything human beings have ever been. So after seeing how small we are, and how much this small world contains, one final question remains waiting very quietly. What feelings should be left in us after all this widening? What kind of perspective belongs at the end, once smallness, fragility, wonder, and meaning have all had their turn? And perhaps that is the feeling that slowly remains when everything else has widened as far as it can. The journey began close to home, with the size of a person against the size of Earth. From there, the frame kept opening. Earth became one planet beside the Moon and Sun. The solar system became a sparse local neighborhood. The Milky Way became one galaxy among hundreds of billions. The observable universe opened into a visible region about 93 billion light-years across. Even that immense horizon began to feel like one patch of something that may continue far beyond what we can ever directly see. By every physical measure we followed, we are very small. That part is clear now in a way it may not have been at the beginning. A human body is tiny beside a planet. A planet is tiny beside the distances of a star system. A star system is tiny beside a galaxy. A galaxy is tiny beside the observable universe. The widening frame kept returning the same quiet lesson. What feels large up close becomes local when the view expands. And yet the story does not end in disappearance. It ends in perspective, because something remarkable remained present through the whole journey. The same small creatures who vanish physically against these distances are still able to notice them. We are small enough to disappear in the scale of the cosmos, yet aware enough to discover that scale at all. We can measure light years, trace galaxies, imagine the history of stars, and ask where the visible universe ends. We can feel wonder about realities so much larger than ourselves that they almost outrun language. That awareness does not make us physically larger. It makes the picture richer. The universe remains immense. Earth remains a tiny world. Human life remains brief. These truths stay where they are, but they begin to rest differently in the heart. once we see that smallness and significance are not the same thing. A person can be cosmically tiny and still live a life filled with meaning. A planet can be physically modest and still carry every memory, every act of love, every piece of art, every grief, every discovery, and every hope our species has ever known. So the final feeling is gentler than defeat. It is true that we are small. It is also true that small things can hold extraordinary value. A voice is small in physical scale. A memory is small in physical scale. A promise is small in physical scale. Yet these are among the deepest things human life contains. In the same way, Earth may be a small shelter in a vast universe, while still being the place where meaning, awareness, and history gather for us. That is enough to change the tone of the whole question. At first, learning how small we are can sound like it should make life feel lesser, but by the end, it can do something quieter and more useful. It can loosen the illusion that we are the center of everything, while deepening the value of the small world and short lives we actually have. It can make Earth feel more precious. It can make human awareness feel more fragile and more beautiful. It can make ordinary moments feel like they belong to something larger without being swallowed by it. A night sky helps with that. When you stand under it, you do not need to hold every number in your head at once. You do not need to picture all 93 billion light years. You do not need to map every galaxy or imagine every unseen region beyond the observable horizon. It is enough to know that the vastness is real and that you are here within it, breathing, looking up, a small being on a small world, inside a universe large enough to inspire awe and calm enough to receive your attention. That may be one of the most peaceful truths in science. We are not large in size. We are large enough in awareness to notice where we are, large enough in curiosity to keep asking, large enough in feeling to find beauty in scales that could otherwise seem cold. The cosmos does not grow smaller for our comfort. We grow more honest in its presence, and perhaps more grateful too. So what remains at the end is simple. We are tiny beside planets, stars, galaxies, and the observable universe. But tiny is still enough for wonder. Tiny is still enough for thought. Tiny is still enough for love, memory, and meaning. And in a universe this vast, that may be more than enough.